Hello, statistics students. Here's another video on visualizing variability with a scatter plot. In this video, we're going to look at how to identify shape. The simplest shape for a trend is linear. Fortunately, linear trends are relatively common in nature. Linear trends always increase or decrease at the same rate. They're called linear because the trend can be summarized with a straight line. In real life, the observations don't fall perfectly on a straight line, but tend to vary above and below a line. For this reason, scatterplots of linear trends often look roughly football-shaped, as shown in Figure 4.4a. Figure 4.5 shows a linear trend from data gathered by one of the authors, who used a Fitbit pedometer to count his daily steps. He learned that his cell phone could also count his steps, though it used a different mechanism for measuring his movements and a different algorithm to turn these measurements into counts. Did the two methods tend to produce the same count? Figure 4.5 shows that there's a linear trend between these two methods of counting steps, which suggests that while the two methods might not perfectly agree, they are measuring the same thing. We've added a straight line to the scatter plot to highlight the linear trend. Not all trends are linear. In fact, a great variety of shapes can occur. But don't worry about that for now. All we want to do is classify trends as either linear or not linear. And this is pretty easy to do by creating a scatter plot of the data and seeing if they follow a linear pattern. Figure 4.6 shows the relationship between levels of the pollutant ozone in the air, measured in parts per million or ppm, and air temperature in degrees Fahrenheit in Upland, California, which is near Los Angeles, over the course of a year. The trend is fairly flat at first and then becomes steeper. For temperatures less than about 55 degrees, ozone levels do not vary all that much. However, higher temperatures above 55 degrees are associated with much greater ozone levels. The curved lines superimposed on the graphs show that this is a nonlinear trend. And as I'll say a couple of times in these videos from chapter 4, we're only going to be looking at linear trends. Nonlinear trends are more difficult to summarize than linear trends. This chapter does not cover nonlinear trends. In this chapter, our focus is on linear trends, and so it's very important that you first examine a scatter plot to be sure that the trend is linear. Applying the techniques in this chapter to nonlinear trends could produce incorrect conclusions. And this concludes this video for visualizing variability with a scatter plot